In this video, I will show you how you can estimate your propeller's thrust and torque using MachUp 5. If you don't know about MachUp, you can watch my previous video about it. Let's start. Open MachUp 5 in your browser window. Now, go to the Add option and select Propeller. You will see a propeller blade on the screen. Now on the right-hand side, you can click on the Geometry tab to change the propeller parameters. Here, you can change the spin direction, the number of blades, propeller diameter, pitch, and hub radius. Make sure to use consistent units. I personally prefer SI units. You can choose to make the blade profile elliptical and adjust the root chord of the blade. Another cool feature is that you get to choose if your prop is driven by an electrical motor. You can toggle this on and adjust various parameters such as motor kV, resistance, battery voltage, etc. This will be useful while doing the analysis. If you don't want to input this information, you can simply select the RPM in the Condition tab. We will look at both methods next. Let's keep the electric motor option selected and go to the Condition tab. You can choose the unit system between SI and English units. Here at the bottom, you can select the throttle setting. If you want static thrust, you can set the velocity to 0. Now, if you don't want to enter the electric motor values, you can go back and toggle off that option. If you go to the Conditions tab now, you will see the option to enter the propeller RPM. With the geometry and the conditions selected, we can run an analysis. Let's do an analysis for a 1045 prop, because we can compare the result with the motor manufacturers later. I will set the diameter and pitch as 10 inches and 4.5 inches, but I will set them in meters by first converting the units. I have tried to make it resemble the prop as close as possible by adjusting the hub radius and root chord, but there might be a deviation from the real test values because of various factors such as the blade profile and airflow. The manufacturer's test data has a test done at 2,940 RPM, so let's use that value. Now I will go to the Analysis tab and run an analysis. Make sure the Forces and Moments analysis is selected. In the prop results, we can see the prop thrust in newtons and torque in Newton meter. If we convert this to grams, the thrust will be around 106.5 grams. Let's look at the test data to compare. As you can see, for the 1045 prop spinning at 2,940 RPM, the thrust is 130 grams. This means our estimate using MachUp can be considered a good starting point. You can follow a similar method if you know your motor and battery specs. I hope you found this video useful. If so, please like and subscribe to the channel. MachUp is a great tool for aircraft and drone designers. To know more about MachUp, you can watch this video. Thanks for watching.